craft blasted off atop an Atlas V.
Main engines up and running and liftoff of the Falcon 9 to the space station.
Engine start has begun, launch command has been issued, and liftoff. Liftoff of the ISS Progress 52 cargo.
And liftoff. Liftoff of the HTV-3 on its way toward the International Space.
And we had liftoff of the Soyuz rocket and the TMA-11M spacecraft on a truly Olympic leap, delivering 3 more crew members to the International Space Station on a historic mission to continue the seamless transition.
To NASA Television's live coverage of the Orbital ATK Commercial Resupply Services 5 launch to the International Space Station. The Orbital ATK Cygnus cargo vehicle, with its 5,100 pounds of science and supplies to deliver, is ready to go on top of its Antares rocket, with everything looking good for today's planned 6:40 p.m. Central Time launch from the Mid-Atlantic Regional Spaceport's Pad 0A at the Wallops Flight Facility in Virginia. We have multiple teams working through today's preparations in anticipation of that launch coming up in about 54 minutes now. At Wallops, there's the Launch Control Center led by Orbital Launch Director Kurt Eberly, the Orbital ATK Mission Control Complex in Dulles, Virginia, led by Cygnus Mission Director Dave Hastman. And of course, we're here at NASA's Mission Control Center in Houston, inside the International Space Station Flight Control Room, led by Flight Director Greg Whitney. I'm NASA commentator Brandy Dean, and I'm joined here today by Amanda Davis, Orbital ATK's Director of Program Engineering at their Chandler, Arizona facility. Amanda will be walking us through all of the work that's gone into getting the Antares ready for launch today. Thanks for flying down to be with us, Amanda.
Absolutely my pleasure. I'm very excited for our launch today, so I'm glad to be here. Thanks.
All right. Well, every launch is exciting, but today's is a little more exciting than usual because it marks the first to take place at Wallops Flight Facility since the accident that occurred in October 2014 during the launch of the 3rd Cygnus mission. And although Cygnus has flown 2 successful missions since then, this past December and March from Cape Canaveral in Florida on Atlas V rockets, this is the first flight of the upgraded Antares 230 vehicle featuring new RD-181 engines. Amanda, I think you played a key part in getting that new design ready to go, so why don't you tell us a little bit about it? Maybe start with the basics of how this new design is different from the old Antares design.
You got it. So we're very excited, of course, to Cygnus be back on top of Antares and back launching out of Wallops. But the big thing that we've done over the past couple years is to change these engines out. So let me introduce you to our new RD-181 engine. There's 2 of these engines that's going to power our first stage. They're built by Energomash, and each one is fully tested through the flight profile and beyond flight duration before we integrate it onto the rocket. These new engines are going to give us more reliability and better performance, and we're carrying an additional 1,700 pounds of cargo to the space station since we have these engines. The next is the first stage core from Yuzhnoye that provides the propellant to these engines. The yellow portion here holds over 21,000 gallons of rocket-grade kerosene, and this blue portion holds 40,000 gallons of liquid oxygen. A stage test where the core and the engines were functioned together were just completed back in May. For 30 seconds duration, everything checked out great. So the next here is the second stage, which is propelled by our Castor 30 XL solid rocket motor. That's produced by our facility in Utah. The motor is another area where we've been continuing to improve and get more and more performance as we go. There's also an avionics structure that's mounted to the top of that, which includes our flight computer, or what I like to call the brains of the business. That's built in Chandler. And at the very top is the avionics structure, is the separation system, which is built by Ruag. And finally, there's a Cygnus spacecraft and its launch configuration. The service module is on the bottom that has our communication, power, propulsion elements, and the big container on top is the pressurized cargo module where all the cargo is loaded. And that's where we got our about 5,000 pounds of cargo today. That's about the equivalent of an extended cab pickup truck. So that's a lot of stuff we'll be taking up to the astronauts today.
I'm sure the Expedition 49 crew is looking forward to its arrival. So how long would you say the team's been working towards today's launch?
We've been integrating these engines together for about 2 years now. I mean, the process is you start with the preliminary design, and then you do analysis, you do a final design, you test. After the test, you learn some things, you tweak the design, and then you get ready for launch. So while 2 years may sound like a long time, it's actually a blink of an eye when you consider the process that we've gone through.
Are you feeling good about it? Everything sounding good for today's on-time launch at 6:40 p.m. Central?
Absolutely. Everything has been very clean today. We've had our little bumps along the road, but obviously we're here today, and so far today has been just a picture-perfect day.
All right. Well, tell us a little bit about your role in all this. What's your background?
So I'm a program engineering manager, and basically what that means is I coordinate with all the technical leads. That includes mechanical, electrical, software, guidance, navigation, control. I make sure all those guys are talking together, and we're meeting the cost and schedule goals together and making sure that we are ready for launch.
All right. Well, it sounds like a pretty big job. Does it keep you pretty busy?
Absolutely. I have to admit, I am one of those lucky folks that love my job.
Oh, well, that's a good place to be. And I guess this is also a good place to be, but not the very best place to be. It would be nice to be actually at Wallops. But I think you've been there before, right?
I've had some quality time at Wallops myself, yes. I learned a lot while I was out there working on the vehicle itself. Most of my time is in Chandler, where we build up the module level, and then out at Wallops, we build up all the way through the rocket and launch. And so when you're out there working with the team, it's really all hands on deck, and you're working towards a common goal. It's a lot of fun.
So what is that team going through right now? What's left to do before our launch today?
Well, about an hour before, I think everyone's nerves are starting to get built up. The time there, as we get closer and closer, you just get more excited. The adrenaline starts pumping. We've been going through checks for 6 hours now. So we start the day about 7-8 hours in front. We're configuring the pad. So the pad team was out there setting regulators and valves and getting that ready. And then the team comes on console. They turn the power onto the vehicle, make sure that all the avionics are working properly, and they've already started propellant loading, so that's another phase. And so that's what they're going through now, and everyone's just got their fingers crossed that nothing goes wrong and we get through this count successfully.
Well, listening to them talking on the loops here from Mission Control, it sounds like everybody's in a good mood and feeling good about today's launch.
Absolutely. I even heard a couple jokes going on the line earlier, so can't complain about that. I think everyone's feeling really good about today.
That's always a good sign. Well, we are again going right into today's launch. It's coming up now in 47 minutes, and you've got a good view here from the pad at Wallops Flight Facility in Virginia. Everything, again, as Amanda just said, is going well and on time for today's launch, and actually the weather forecast is 100% favorable for today, which is very unusual and definitely good news. We had a few bumps along the way getting here with weather. First, hurricanes here in the U.S. and then in Bermuda over the weekend, and so we're glad to see that all that's cleared up, and looks like everything will be great for today's 6:40 p.m. Central Time launch of the Orbital ATK resupply commercial resupply services 5 launch. We've got about 45 minutes to go until today's launch of the Orbital ATK Cygnus cargo vehicle, and about 1,100 pounds of its cargo is going to be contributing to the more than 250 science experiments going on board the International Space Station. One of them being carried up by Cygnus's Cool Flames experiment, and we're going to go actually now to Wallops itself to hear from my colleague Catherine Hamilton, who has Liz Warren on hand to talk about that and other science going up on Cygnus. Catherine?
Thanks, Brandy. We're here at the viewing site, and you can see Antares behind us in the landscape. And I'm joined here with Dr. Liz Warren from the National Lab, and she's going to tell us a little bit about the science that's going up to station. You can definitely feel the excitement out here. And Liz, tell us, what are you most excited about?
I am most excited about the incredible laboratory that we have in orbit right now. It's about as big as a football field. It weighs 1 million pounds. It just flew over the launch pad just a little while ago. It's going to fly over again, and Antares is going to go meet it with Cygnus in just a couple of days. One of the great benefits of having a laboratory in space is exposure to microgravity. For a scientist, being able to control gravity as a variable enables us to open up all kinds of new findings for whatever field of research you happen to be looking at, whether it's combustion or life sciences, physical sciences, human research, and even technology demonstration. So it's something that is extremely exciting for scientists to take advantage of our incredible International Space Station. I work for CASIS, the Center for the Advancement of Science in Space, and we are privileged to be able to manage the National Lab portion of our International Space Station. That means we're providing access and enabling technology hardware to users of the space station, which include the research community, academia, industry, and other government agencies.
Thanks, Liz. We're also joined by Jess Robbins from NASA's Glenn Research Center. And Jess, I know you're studying fire in space with an investigation called Cool Flames. Can you tell us what exactly is a cool flame?
Well, a cool flame is a lot like the hot flame that burns in a spherical shell around our liquid droplets in our current investigations. The cool flame burns at a much lower temperature, hence the name cool flame, and it burns much more cleanly and more efficiently, which we're hoping can be harnessed in newer generation piston engines here on the ground.
And what does a cool flame look like?
Well, we don't know yet because currently the diagnostics we have on orbit are insufficient to image the cool flame itself. But the hardware we have going up on Cygnus today will provide us that ability to actually image for the first time the flame around the droplet during the cool flame section of the burn.
Very cool, no pun intended. Liz, I know there's some great new hardware going up to station tonight as well that offers new opportunities for future researchers that want to do research and science aboard the space station. Can you tell us a little bit about those?
Absolutely. So at the National Lab, we're not only shepherding new researchers to the space station, we're looking forward and providing enabling technologies and hardware that will enable future researchers to come on board and do research on the space station. A couple of examples are something called the Controlled Dynamics Locker, which is made by Controlled Dynamics Incorporated. And I explained microgravity earlier. It's a great thing to have. It's a great variable to be able to control gravity. But the Controlled Dynamics Locker enables investigations to have an even more pristine and pure, quiescent microgravity environment. The space station itself is so giant that there's little vibrations and jostles that are associated with people living in space and equipment operating on the space station. So the Controlled Dynamics Locker allows certain investigations to free float away from vibration. So really it's an active vibration isolation system. So that's one item. Another exciting enabling technology that we have on the space station includes the additive manufacturing facility, which is really a 3D printer in space. We've actually got a couple of different units on the space station for doing 3D printing. Another example is something called the NanoRacks Black Box. And this is a great facility for scientists, including young people in education right now, like students, to fit their experiment in a small box that can have access to power and data. And it's pretty much just a modular, if you can fit it in the box, NanoRacks will fly it and attach it to their equipment in the space station. You'll be able to control and see what's going on inside of your investigation. So that's another great enabling technologies that we've got. And if you're looking for outside of the space station, exposure to the environment of space outside of the space station, we have a NanoRacks external platform, which is also another place where you can get data and power to something that you want to expose to the space environment, which includes radiation, atomic oxygen, exposure to micrometeorites, and extreme temperatures and extreme vacuum. So that's a really exciting enabling technology as well.
Thanks, Liz. Well, that sounds like we have a lot of really great stuff heading to the station tonight. And that's about all the time that we have for this evening. And back to you, Brandy.
Thanks, Catherine. We're now about 39 minutes away from today's launch. At 6:40 p.m. Central Time, Antares will lift off the launch pad there at Mid-Atlantic Regional Spaceport in Virginia and begin a 2-day journey to the International Space Station. Amanda, now is probably a good time to go over what will happen after today's liftoff. Can you run through what we should expect as the Cygnus makes its way to orbit?
You bet. So right after liftoff, we'll have stage 1 burn. That will go for about 3.5 minutes. And then after that, we go into what we call the coast phase. So we separate the stage 1, and then you wait for about a minute. I liken this to when you're in your car and you let off the gas and you see the miles per gallon go really high. That gives us some more distance without having to use any propellant. So during this coast phase, we also take that opportunity to do the fairing deployment and the interstage separation.
Maybe explain what fairing and interstage is.
Oh, sure, you got it. The fairing is actually what protects Cygnus as we lift off through the atmosphere. So when the rocket takes off, there's going to be a lot of pressure loads and there's going to be a lot of heating. And Cygnus is designed to burn up when it comes back into the atmosphere, so it can't take those levels. So we put a nice protective fairing on it, and then we jettison that once we're out of the atmosphere.
Okay, got it.
Okay, so after that, we do stage 2 burn, and that takes about 2.5 minutes. And then we go through one more coast phase for 2 minutes. And that coast phase really allows us to make sure that all the accelerations are ideal and that Cygnus is pointed in the right direction. And then we release Cygnus. And then from there, Cygnus starts to do some of its initial checks. And an hour and a half later, they deploy their solar arrays. And then from there, well, the next 2 days, that's where we're doing a series of these delta V burns, which basically means that they're using their propellant to slowly raise it up towards the space station. That way, folks here in Houston can check out to make sure that Cygnus is healthy and responding correctly. There's a series of go, no-goes, and then eventually it raises up all the way to station. And then the Canada arm comes out and grapples it and docks it into the space station.
That sounds great, I guess. And it's planning to arrive at the space station on Sunday, a little longer trip than usual to give it actually extra time to make room in the space station's agenda for another arrival. The Soyuz TMA is carrying Shane Kimbrough and his crew members to launch on Wednesday. Will be taking its time getting its own 2 days to get to the space station, and then the Orbital Antares or Orbital Cygnus will arrive afterward. But, you know, we've already gone over the Antares and its modifications. I know that Cygnus also had some modifications and enhancements, so maybe you can tell us a few details about it now.
Sure, you got it. So one of the things we did was we went to this enhanced pressurized cargo module. So that is the big container you see on top. We increased the length of that to give us 43% more capacity. So that's why the launch vehicle continues to grow, so we can carry more and more cargo in that cargo module. So we've done that. We've also added the UltraFlex solar arrays, and those are much lighter. You kind of see them, they're different looking. They're round instead of the rectangle ones that you're used to seeing. And so those are actually, they pack down really small and they're much lighter weight, but yet they still supply enough power to Cygnus. So that's one of the other ones.
I guess the lightweight is nice because the less weight you carry into orbit, the more you have to devote to cargo for the space station crew.
That's right. So the less you have in your spacecraft, the more M&Ms, apples, tortillas get to go to the astronauts.
I'm sure they appreciate that.
I hope so.
This particular Cygnus has been named for former astronaut Alan Poindexter. He was selected to the astronaut corps in 1998 and made 2 trips to the space station. He first piloted Space Shuttle Atlantis to the station on STS-122 in 2008 to deliver the European Columbus Laboratory. And then he returned in 2010 as commander of Space Shuttle Discovery for the STS-131. On that trip, he helped deliver a good deal of supplies and hardwares, including new sleeping quarters for the crew and new science equipment. He retired later that year and then died in 2012. So Orbital ATK chose to call this Cygnus the SS Alan Poindexter in his honor. Everything's still looking good and on time for a launch in 34 minutes and counting now. That'll be coming up at 6:40 p.m. Central Time, launching from the Wallops Flight Facility in Virginia. One of the other enhancements, I think, to Cygnus was that you're able now to load science on later. Is that right?
That's correct. That's another thing we've been working on, and this is actually going to feed into mission to Mars. So there's a lot of science experiments that are time sensitive. We have a control sample here on the ground and something we need to get to orbit as soon as possible. So the later we can load the cargo for those sensitive science experiments, the better. So one thing we've been working on is both operational as well as design changes. So now we can operationally load Cygnus a lot faster, and for the CRS-2, the follow-on contract for commercial services, we'll be able to load things from the pad. So we're working on design changes now that are very exciting. We'll be able to load and basically get cargo into space in less than 24 hours.
Wow, that's impressive. It seems amazing to be able to do that. I guess this is your 6th out of 10 missions that have been planned so far, and you think you'll continue making improvements as you go?
Absolutely. We do have improvements planned as we go. We want to carry more and more cargo, and we have more enhancements on the line for this contract, and then CRS-2, we have even more. We're going to continue to improve and meet whatever NASA needs us to do.
All right, that sounds good. Still looking good as we head towards a 6:40 p.m. Central Time liftoff. That's just over 30 minutes away now, 32 minutes to be exact. And everything continuing to go well in our countdown today. We're getting closer to today's launch, now just 31 minutes away, and we're going to go back to Wallops now and hear from my colleague Emily Ferfaro on the NASA social media team. She's been spending the past couple of days with the NASA social participants at Wallops, and she's got a couple of them to give us an update on what it's like to be there in person. Emily?
Hi everyone, thanks Brandy. I'm out here, I'm Emily Ferfaro. I do social media from NASA headquarters, and I'm joined out here with some NASA social attendees for the launch of Antares. So a NASA social program, if you're not familiar, there are these awesome events that we hold for a lot of launches and mission activities where anyone can apply and you get to come to our different centers You get behind-the-scenes tours of the centers. You get one-on-one time with scientists and mission experts, which is really awesome. And then you also get to learn a lot about the missions and the different science experiments that are going up to station, especially for this launch. So, Michelle, tell us a little bit about yourself. Where are you from, and what do you do?
I'm Michelle Mercurio. I live in Richmond, Virginia, and I own a small social media marketing firm that helps small businesses tell their stories.
Awesome. And we're also joined here by Kennedy. Kennedy, why don't you tell us a little bit about yourself?
Hi, I'm Kennedy Perry. I am a junior at Westchester University. I come from around the suburbs of Philadelphia. I'm studying communications with a minor in geology, so this NASA Social is just awesome.
Awesome, thanks. So have either of you seen a launch up close before?
I have not.
So excited.
This is my first NASA Social and launch up close as well.
I wish we could do an interview after to get their reactions. It's going to be awesome. So what kind of things have you guys seen at NASA Wallops since you've been here?
So behind the scenes tours, we got to hear Charles Bolden speak. That was pretty amazing. We got to hear Kay Heyer speak about her Endeavour mission, and we got to meet some great other social attendees.
Yeah, exactly what Michelle said. We have met so many amazing people, and just hearing their advice on anything NASA related and even just future endeavors for us as well. And going into the HIF had to be my favorite part of this entire NASA Social. I saw pictures of it prior and I couldn't even believe I was standing in there. It was amazing.
Great. So in addition to this cargo launch, like what other kinds of things have you learned about this mission exclusively?
So I think one of the cool things that really impressed me was all the experiments that are on board. I think that it's very cool too that there is a robot, the Sphero robot, that is getting launched into space, and 6 different schools throughout the country actually had students write open source code for experiments that are going to be performed on the International Space Station. And the fact that it's interactive education, it's part of what's happening here in the classroom, but it's also happening in space. That was probably one of the coolest things that I've learned.
Exactly what Michelle said. I mean, that was awesome. I have to say, just learning about all of the cargo that was going on to the Antares rocket, that just amazed me. I did not know much prior to this NASA Social, so just speaking with everyone, learning about the cargo, learning about what it took to get to this point, now that we're doing a relaunch, the return to flight, it is so exciting. Yeah, it was awesome.
What was your favorite tour stop yesterday when we went through NASA Wallops campus?
Probably seeing the rocket up close and personal. I think between crying and jumping up and down and giggling, that was probably my favorite part. But seeing the rocket up close and personal, and just knowing probably, hearing from Charles Bolden and hearing about all of the work that the people have done to make this mission happen, I think that was probably my favorite.
My favorite yesterday was probably speaking with Kay Heyer, really hearing about her trip on the International Space Station and being up into orbit. Just hearing it firsthand from somebody and their experience was so amazing. It just is something not everybody gets to experience, and to hear what she goes through and to see a video all about it, and seeing that they had a little, Mardi Gras party up there was amazing. I thought that was awesome.
With the Mardi Gras flags sticking
Yes, it was awesome. Kay Heyer was amazing.
Awesome. So if you could tell people one thing that stood out to you about the NASA Social, what would you tell them?
Aside from the absolute incredible experience and the science and the experiments and everything we're learning, the people have been amazing.
I'd have to agree. Meeting everybody was an amazing adventure in itself.
Awesome. That's all the time we have today. Back to you, Brandy. Thanks.
Thanks so much, Emily. Sounds like you're having a great time out there, and if you want at home to look into other opportunities to participate in NASA Socials for other events, you can keep an eye on nasa.gov or one of the many NASA social media channels. You can find us on Twitter at NASA or on Facebook at facebook.com/NASA, just to name a few, and there are many more that you can find listed online. We're about 26 minutes away from launch now, and coming up on the 10-minute hold that starts at L-18 or 6:22 p.m. Central. Amanda, maybe you can tell us a little bit about what goes on during that hold and why we build those into the timeline.
Well, as you can tell, there's a lot of operations we have to do as we get towards launch, and sometimes those operations don't follow exactly on the timeline. So we build in some holds to make sure that we have some contingency to make sure we hit the window. Our launch window is only 5 minutes long, and the reason that is because we're optimizing how much cargo we can send to hit the space station to be able to get there. And so with that really strict small 5 minutes, we make sure that we are able to build in a little contingency, a little pad in case operations ran over. We can also elect to hold a little longer in case we want to go to the end of the window. Why would we want to do that? Well, maybe there's something with the weather that we're still checking or some range requirement. Thankfully, none of those have been red or yellow today, so we shouldn't have to wait till the end of the window today, but that's why we have those, so we can have a little bit of time and get everything done at just the right moment.
All right, then that again is coming up at the L-18 point. We're still at L-24 now, so that's coming up in just a few minutes. Why don't you tell us a little bit about your time on the flight control team, Amanda? I know you've been in this position a few times, and you can give us an idea of what it's like up there.
I don't know which one's more stressful, being on the NASA TV console or the other two I've performed were the upper stack lead. That one I'm checking on pressures and temperatures and electrical parameters of the upper stack and making sure everything looks good before liftoff. The other one I've done is pad manager, and that makes sure that all the folks that are doing the final configurations on the pad, that they evacuate in enough time, that they're keeping track of their time and that they're going to get everything done according to the timeline, and if there's any red teams. So what happens there is if we find an issue, we need to go make a regulator adjustment, change pressure of something, then we send a team out to do so, and that takes a lot of coordination with safety and the Wallops range to do so. So those are the couple of jobs I've done.
Which was your favorite?
You know, I liked the pad ops because that's actually out on the island, so you can really feel the rumble of the vehicle when you're on the island versus when you're back in the range control center on the main Wallops base there.
And when it's really getting low in the countdown and you're just about to launch, can you explain for those who haven't been there what that feels like?
Well, it's just really exciting. Those last few moments as we're going into the final countdown, you're hearing them arm and take the vehicle to internal power, and you know that that's the very last moments, and you're committing everything, and nothing's gone wrong, and you're just waiting to make sure that there's no reason to abort. So it just gets more and more exciting. The closer you get, the less possibility there's for something to go wrong, and that we're going to go launch this. And it's just a lot of butterflies, a lot of nerves, and a lot of excitement.
And we talked earlier about what it takes for Cygnus and Antares to get ready for launch, but what about the flight control team? What do they do to get ready?
Well, they do a lot of practice as well. So one thing that was a good benefit is that we just conducted the stage test, and we do that a lot like a launch. We have a lot of that team there, so they conduct the same countdown and to do that hot fire. But we also do a mission dress rehearsal where everyone gets on and we go through the count and make sure everyone knows what their jobs are. And there's fake telemetry, so it looks like a real launch. And then we also do fake anomalies, so that way you learn how to work through problems together and how to work the different nets. So what we hear online is the countdown net, and there's a lot of nets in the background for engineering and the loading and a lot of other ones that are being used, and so you learn how to switch back and forth and how to monitor different nets.
How long did it take you to get used to that and feel comfortable doing it?
You know, I used to play a game when we were doing the initial loading of the vehicle, what we called the 5K series, which is just loading the propellant and offloading the propellant. I would see how many different nets I could actually listen to, and I finally got up to 12.
Wow. That's impressive. 12 voices in your ear, basically, right?
Yeah, not all at the same time, but you're trying to monitor different conversations, and you can get a headache if you try that too fast.
All right. Well, what about between now and launch, which is 21 minutes away now, just about to the point of that 10-minute hold? But what should we be listening for? Is there anything that you can see, maybe causing a problem at this point that would delay us, or everything looking good?
I would say everything is looking really good, but you never know. So as we go into the final countdown, like I said, we're doing some of the final arming sequence, going on to internal power. At the 3-minute mark, we go into an auto sequence. So that basically means that we don't have our operators on the ground pushing the buttons to bring the rocket up to its launch point. The flight computer on board is taken over. Now that doesn't mean there isn't a chance for an abort, but that is kind of where you're hands off and you're just waiting to let it go.
All right. Well, here's hoping that we get to do that today, and it looks like things are going well, and we should, right?
That's right. Go Antares, go Cygnus.
Okay. As promised, with that 18-minute mark having come and gone, we are now in a 10-minute hold that starts at L-18. That'll get us through the next 10 minutes while the team just makes sure everything is ready to go and looking good, which it is, so they shouldn't have a lot to do during this time. But in the meantime, in addition to all this work that's going on for tonight's launch, there's another vehicle already in production at Wallops as well, right, Amanda?
That's correct. I mean, there's no rest for the wicked here. We'll continue processing OA-7 right after we're done with this one. So the day after the launch, we go out and we start to bring the tail back and do some refurbishments on that. There's a little bit of refurbishment on the pad typically, but then we're going to continue work on OA-7, which will be our next resupply mission. Date still TBD when NASA needs it, but we're preparing for the next one.
All right, good. And I'm sure we'll have more cargo ready to put on it.
Absolutely.
What will your role be in that preparation?
Well, I'll still continue doing my day job, so to speak, which is not NASA TV. No, it'll be to make sure that the upper stack is prepared and ready. So that is something that we build up in Chandler, and we do testing on that, and then we send it to Wallops for integration with the first stage. So that's in continuous production. In fact, we're on OA-5 on the upper stack at Chandler right now.
Excellent. Sounds good. For those just joining us, welcome to live coverage of the Orbital ATK Commercial Resupply Services 5 mission launch to the International Space Station. The Cygnus cargo vehicle, which you're seeing here, is sitting on top of the Antares rocket there on Launch Pad 0A at the Mid-Atlantic Regional Spaceport at Wallops Flight Facility in Virginia. And everything is looking good for the planned 6:40 p.m. Central launch coming up here in just 15 minutes now. Antares will be making a 9-minute and 4-second climb to orbit before separating from Cygnus, which will then go on to make its way to the International Space Station with some 5,100 pounds of supplies to deliver, including 1,293 pounds of scientific cargo. Generally, that journey to the station would take Cygnus about 2 days to make after arriving on orbit, but for this mission, the timeline is extended to make way for the launch and arrival of 3 new crew members at the International Space Station. NASA flight engineer Kate Rubins is already at the station and awaiting Cygnus's arrival, along with Russian Commander Anatoly Ivanishin and Japanese flight engineer Takuya Onishi. But on Wednesday, NASA astronaut Shane Kimbrough and Russian cosmonauts Andrei Borisenko and Sergei Ryzhikov will be launching from the Baikonur Cosmodrome in Kazakhstan and beginning their own 2-day journey to the space station. So, to give them room to arrive and get settled in, Cygnus will instead aim for a berthing to the space station at 6:05 a.m. Central on Sunday, October 23rd. Rubins and Onishi will be at the controls of the station's Canadarm2 robotic arm that day, ready to grab onto it so that controllers on the ground here can move it into place on the bottom part of the station's Unity node. Cygnus will spend about 5 weeks in space before the crew uses the robotic arm again to unberth it from Unity and send it on its way. But in those 5 weeks, there will be a flurry of activity to unload the supplies and hardware it's delivering. There should be a number of things the crew will be excited to get, including a number of interesting science experiments. One is the Cool Flames experiment, which is building on the findings of a previous experiment at the space station, FLEX, that showed scientists that cool flames, or flames that burn at low temperatures with no visible flame after a hot ignition, don't burn as models predict they will in microgravity. That experiment will test a number of different fuels and additives in the station's combustion integrated rack to see what temperatures they burn at in low gravity. The information could help develop more safe, efficient, and environmentally friendly engines and fuels for use in space and on Earth. And one science experiment that the crew won't be unloading is the Sapphire 2 experiment. That's the second of a set of 3 experiments that looks at the development and spread of large-scale fires in low gravity. Fires too large to study in the combustion integrated rack or even on a spacecraft with people on board at all. Inside Cygnus, there's a set of several materials that you'd likely find on a spacecraft: the flame-retardant clothing worn by astronauts, the plexiglass used in windows, storage containers, and silicon components. After Cygnus is safely undocked and moved away from the space station, the Sapphire hardware will ignite a flame to burn the material, and avionics equipment that's part of the experiment will gather information on how it burns using a suite of sensors, video cameras, and signal processing equipment. All of that information will be sent down to scientists on the ground before Cygnus itself is then allowed to burn up in the Earth's atmosphere as usual. Scientists will be looking at how the flames spread and grow across the materials, samples to test out NASA's material selection methods, and verify our fire protection strategy. It's difficult to do safely, so Cygnus is offering us an invaluable chance to improve our knowledge base. We're now just about 11 minutes away from launch, and flight controls teams here on the ground are getting ready to begin their go, no-go poll, checking with each discipline and control team to make sure all the bases are covered and everything is ready and in place for a 6:40 p.m. Central Time liftoff today. Orbital launch conductor Adam Lewis just got a go from the team and is ready to restart the countdown clock. We'll be picking up in just a few minutes now, 8 minutes before or just a few seconds now, 8 minutes before today's liftoff of the Orbital ATK Commercial Resupply Mission 5 launch. And that again is coming up in 8 minutes and 40 seconds now at 6:40 p.m. Central Time. So Amanda, maybe you can tell us a little bit about what's left to do in these final minutes before launch.
Well, at this point, we're going to internal power. So at this point, we've been powering the vehicle from ground power. And of course, when you lift off, you can't use ground power anymore. So we go to the batteries on the vehicle. Then we're also telling everything that you're armed and you're ready to go. That means that all the ordnance will start firing according to the sequence. And eventually at 3 minutes to go, which is really close, I keep looking up at the clock, at 3 minutes to go, we go into that auto sequence start. And that's where the flight computer takes over and tells the vehicle where to go. In the last few seconds, as we're starting the engines up, we do some last-minute checks. So there's still a chance right at the very end, as we're doing engine startup, we do some wiggle tests to make sure the TVA is working properly, and then we go into the final count and liftoff.
All right, and everything, as you said, still looking good. Weather still cooperating. Everything looking like we are heading towards liftoff right on time at 6:40 p.m. Central.
It's been a very smooth count. I'm very excited to see Antares liftoff.
With the weather behaving so well, we actually have a chance for those on the East Coast to possibly be able to see the launch from where you are, particularly in the Washington area. The launch should be visible at least 10 degrees above the horizon for about 90 seconds after liftoff. Now 5 minutes away from today's 6:40 p.m. Central launch, and looking at a close-up view of the Cygnus cargo craft on top of its Antares rocket, ready to go. Everything proceeding very smoothly into tonight's countdown as we head towards that final liftoff. Again, just 4 minutes and 42 seconds and counting. Now 3 minutes and 30 seconds away from today's 6:40 p.m. launch. At this point, we go into the terminal countdown. Any red flags that crop up between now and launch will stop the countdown, but at the moment, everything continuing to look good. Send Cygnus and its 5,100 pounds of cargo off to the space station on time. We're hearing now that the launch control team is going to take advantage of that 5-minute window and actually slip out to 7:45 p.m. Eastern Time. That's 6:45 p.m. Central Time. So we're going to have a little bit of extra time before tonight's launch, about 5 minutes. So we are now 6 minutes and 13 seconds until tonight's now 6:45 and 46 p.m. Central Time launch.
Flight Control, I got your call that we have FA ECS transferred to TN2. Is that correct? That's firm. And ops 2, your go for step 423. Deactivate BRG.
BRG deactivated.
Copy that. And NASA TV report range status. And NASA TDLC countdown 1.
Go ahead.
Yeah, report range status.
Range is green.
Copy, range is green. Okay, launch team, just be advised, we've retargeted our T0 to the end of the window at 234536. We've completed all steps through step 424, the final countdown. Ops 1, step 425, we go to transfer avionics to internal power.
In work. All internal power on, all external power off. Step complete.
Copy, Ops 1, check 425, elect 1, you go for 426.
LC elect 1, internal power nominal.
Copy, check 426 complete. Ops 1, step 427, go to open FTS umbi loop and verify green indication.
FTS umbi loop open and green.
And FTS verify STLU status.
LC, STLU, and FTS receiver indications are nominal.
Copy, FTS, check 428. Ops 1, activate arm enable.
Arm enabled.
And Ops 1, send all arms command.
All arms sent. Complete.
Check 429, check 430. Elect 1, you go for 431.
Still counting down towards today's launch, now set for 6:45 p.m. Central Time. Things looking good now with that new time, taking advantage of the 5-minute launch window that Cygnus and Antares has. That gives the team here on the ground a little time to troubleshoot a minor issue they saw with the engine, but again, that seems to have resolved, and we look like we are heading down now 3 minutes and 44 seconds away from tonight's launch.
And SIGI verify SIGI nav mode nominal.
LC, SIGI nav mode nominal.
Copy that. Check 43 and 434. Phase 3 dynamic limits will be active at T-minus 3 minutes.
Three minutes now to launch and counting. We are back now in that terminal countdown phase, heading towards a launch again. 6:45 and 46 seconds tonight.
Controls and transfer to CSOE.
BTSO is open.
ODM bus voltages and currents nominal.
Copy all elect 1 and core 1. I copy your transmission. Check 441 complete. EHS1, I'll wait for your call on 442.
EHS charging is nominal.
Copy, EHS1, check 442 complete. And we'll be at T-minus 2 minutes on my mark. Mark.
Just 2 minutes to go now. It'll take the Cygnus about 9 minutes and 4 seconds to reach orbit and separate from Antares before it can then begin making its way to the International Space Station and scheduled to deliver 5,100 pounds of cargo to the station on Sunday.
T-minus 1 minute and 30 seconds on my mark. And mark.
Core 1 preliminary tank pressurization started.
Copy, Core 1, check 446. T-minus 1 minute on my mark. Mark.
Just 1 minute to go in tonight's countdown. Everything looking good and proceeding smoothly for a 6:45 p.m. Central Time launch.
Copy, Core 1, check 448. And T-minus 30 seconds on my mark. Mark.
30 seconds now.
T-minus 10 seconds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. As you can see, Cygnus lifting off on top of its Antares rocket on its mission to deliver supplies and science to the International Space Station.
EHS and TVC are nominal.
The first stage is now burning and will burn for 3 minutes and 20 seconds of flight before it cuts off at just about 3.5 minutes into the flight. That provides the initial thrust to get Cygnus going on its journey to orbit.
Altitude is passing 10,000 feet. Engines are throttling to 55% power.
Now more than 10,000 feet above the Earth, and everything proceeding smoothly.
And core pressures remain nominal. Vehicle engines are back up to full power. Nominal chamber pressure on the main engine. Power remains nominal. Altitude passing 30,000 feet. Engines remain nominal, as do core pressures.
Crowd watching the launch at Wallops there, cheering its liftoff. We're now 1 minute and 30 seconds into flight. Another minute and a half or 2 minutes to go until the first main engine cutoff, coming at 3 minutes and 28 seconds. But everything proceeding as expected in today's flight.
Core pressure, main engine systems, and TVC remain nominal. So nominal, we're about 90 seconds from MECO at this point. Attitude remains nominal. Just passing 100,000 feet in altitude. Stage 1 systems continue to perform very well. Vehicle attitude is nominal. Engines and core pressure remain nominal at this point. Avionics systems continue to look good. Healthy power systems.
2.5 minutes into flight, less than or just over a minute left to go before that main engine cuts off.
Altitude just passing 200,000 feet. Attitude remains nominal. We started our slow throttle transition. Attitude and core pressures remain nominal. Roughly 30 seconds to main engine cutoff. Velocity is 10,000 feet per second. Engines have throttled back to 55% power. Altitude 300,000 feet. TVC skew for MECO is initiated. Attitude remains nominal. Engines remain nominal. And we have main engine cutoff. PSS disable and stage 1 separation. Storm is
here and there that everything is continuing as planned. The main engine's cut off right on time, and the first stage separated from the rest of the Antares rocket. Coming up next at the 4 minute and 9 second mark, we'll have fairing separation. The fairing protects Cygnus through the early part of launch as it's flying through the denser part of the Earth's atmosphere. That again will be at 4 minutes and 9 seconds.
Stage 1 Delta Phi was nominal. At this point, we're in, and we have fairing separation.
And there you see an animation of the fairing separating, and here that that happened just as planned. After that, the
TVC batteries initiated, and stage 2 ignition.
There it is. Stage 2 ignites, and that will be burning for 2 minutes and 40 seconds to continue Antares and Cygnus's climb into orbit.
The Castor 30 XL will burn for about 2.5 minutes. Castor 30 XL TVC performance is nominal. Attitude remains good. Vehicle power systems remain nominal. Attitude's nominal. Not seeing much consumption from the attitude control system.
Now 5 minutes into today's flight, everything continuing to go smoothly. You can see it's continuing to climb into orbit and take Cygnus and its 5,100 pounds of cargo on its way to the space station.
Attitude remains nominal. Power systems remain good. Altitude is 190 kilometers. We're about 90 seconds from stage 2 burnout.
Minute and a half left for stage 2 to continue firing. Then it will burn out once Cygnus and Antares reach orbit.
Just continuing stage 2 burn here. Vehicle attitude looks nominal. All vehicle systems appear very healthy. Vehicle attitude is nominal. Power looks good.
Just 1 minute left for stage 2 to continue burning.
Attitude remains nominal. Altitude is 210 kilometers. Attitude remains nominal. Power is nominal. Should be coming up on motor tail-off right now. We see the start of the motor tail-off at this point. Attitude remains nominal. Altitude is 220 kilometers. Motor pressure continues to tail off as we head towards burnout. And we have stage 2 burnout. Antares is in orbit.
Antares and Cygnus safely in orbit now, and stage 2 having finished its part of the climb into space. Got a couple more minutes now before the next milestone, which is when the Cygnus cargo craft will separate from Antares and let the rocket fall away. That'll be taking place at 9 minutes and 4 seconds into launch, so just a little over a minute and a half left for that.
Power systems still look good. Vehicle attitude is nominal. Vehicle power systems and attitude remain nominal at this point. Again, we're just awaiting payload separation shortly here. Attitude and power remain.
8 minutes now into today's launch, and again, as you're hearing, everything continuing to look good. We're waiting for the separation of the Cygnus cargo craft, which will take place at the 9 minute and 4 seconds mark.
Of nitrogen from the second stage attitude control system.
Cygnus is carrying with it 5,100 pounds of cargo, including more than 1,000 pounds of scientific equipment and samples that will be used in the many science experiments that go on board the International Space Station at any given time.
Attitude and power are nominal. Waiting payload separation shortly here. All systems still look good. Attitude is nominal. And we have Cygnus spacecraft separation.
And you see an animation of the Antares pulling away from the Cygnus cargo craft, which will continue on its own to make a several-day journey to the International Space Station, scheduled to arrive on Sunday.
Like we've got good injection of Cygnus into the intended orbit. With that, we're going to sign off from the RCC and wish Cygnus a smooth journey to the International Space Station.